Okay, next problem that we have is, this is basically NCERT problem. Raindrop of radius 2 mm falls from the height of 5 meter above the ground. Okay, so you have a raindrop which is falling from the height of 500 meter above the ground. It falls with decreasing acceleration due to viscous resistance of air until half the original height. Okay, so half the original height it falls with the decreasing acceleration. What is the meaning of decreasing acceleration? That means from here till here the motion is non-uniformly accelerated. So from here to here, due to air friction, the motion is non-uniformly accelerated. Obviously एक तो ग्रेविटी का फोर्स लग रहा होगा, दूसरा एयर का फ्रिक्शन लग रहा होगा, विस्कस फोर्स. तो ड्यू टू द कॉम्बिनेशन ऑफ बोथ its acceleration is continuously decreasing as it is falling from this height. Now please pay attention here. Decreasing acceleration does not mean decreasing velocity. ऐसा बिल्कुल भी नहीं है, राइट. फर्स्ट ऑफ ऑल व्हाट इज एक्सेलरेशन? एक्सेलरेशन का मतलब होता है रेट ऑफ चेंज ऑफ वेलोसिटी. वेलोसिटी डिक्रीज नहीं हो रही, रेट ऑफ चेंज ऑफ वेलोसिटी डिक्रीज हो रही है. यानी कि अगर मान लीजिए पहले मान लीजिए कि कोई पार्टिकल है जिसकी जो स्पीड है दैट इज 1 मीटर पर सेकेंड, राइट. एक सेकेंड बीता, आफ्टर 1 सेकेंड मान लीजिए इसकी वेलोसिटी हो गई 10 मीटर पर सेकेंड, राइट. आफ्टर 1 more second, let's say इसकी वेलोसिटी हो गई 15 मीटर पर सेकेंड. आफ्टर 1 more second, let's say its velocity is 12 मीटर पर सेकेंड. See what is the change in first second? Change in velocity is +9. What is the change in velocity in next 1 second? +5. Change in next 1 second let's say this is 17. +2 meter per second. Now see, rate of change of velocity is basically decreasing, right. पहले 1 सेकेंड में 9 का इंक्रीज हुआ, अगले 1 सेकेंड में सिर्फ 5 का इंक्रीज हुआ, अगले 1 सेकेंड में सिर्फ 2 मीटर पर सेकेंड का इंक्रीज हुआ. वेलोसिटी तो स्टिल बढ़ रही है 1, 10, 15, 17, बट रेट एट विच द वेलोसिटी इज चेंजिंग इज डिक्रीजिंग. पहले 1 सेकेंड में 9, अगले 1 सेकेंड में 5, अगले 1 सेकेंड में 2. सो अगर आपका एक्सेलरेशन डिक्रीज हो रहा है, दैट डज नॉट मीन दैट वेलोसिटी इज डिक्रीजिंग, राइट. सो इसके अंदर कोई भी किसी को कंफ्यूजन नहीं होना चाहिए. कमिंग बैक टू द क्वेश्चन, फ्रॉम हेयर टू हेयर द एक्सेलरेशन इज डिक्रीजिंग, right. Acceleration decreasing, that means we have a non-uniformly accelerated motion, right. Acceleration decreasing but velocity is increasing, right. ऊपर से जब नीचे आएगा तो velocity तो बढ़ रही है, right. तो velocity यहाँ से मान लीजिए यहाँ से ड्रॉप होना स्टार्ट हुआ तो velocity was 0, यहाँ बढ़ते बढ़ते तो velocity has become v, right. So it attains maximum speed and moves with the uniform speed thereafter, right. So from here to here it is moving with the uniform speed v, right. So it is uniform motion, right. What is the work done by the gravitational force on the drop in first and the second half of the journey, right. You have to find the work done by the gravity from here till here, then from here to here. Now please note one more thing. Here the drop is not under free fall, right. Free fall कर रहा होता तो continuously उसकी velocity बढ़ रही होती at the rate of 10 meter per second square, that we know. It is not under free fall, right. Obviously there is a force due to gravity, but there is also force given due to the air friction that was mentioned in the question. Okay, let's calculate the work done by the gravity in first half. Okay, let's first focus on the gravity word, right. जब भी आपसे वर्क डन निकालने के लिए पूछा जाए, आपका सबसे पहले ध्यान जाना चाहिए किस फोर्स का वर्क डन आपको निकालना है. आंखें बंद करके आपको स्टार्ट नहीं हो जाना. यू हैव टू पे द कॉन्सेंट्रेशन ऑन द वर्ड. आप किस फोर्स का वर्क डन निकालने जा रहे हो. I have to find the work done by the gravity, right. Okay, so work done with the gravity will be equal to force Fs cos theta, right. किसका force? Gravitational force, that is mg. Displacement, first half में कितना displacement हुआ? That is 250 meter. That is your displacement. Cos theta, angle between force and displacement. Force is this way, displacement is also downwards, so angle is 0 degree, so cos of 0. So the mass is given to be, what is the mass of the raindrop? Mass of the raindrop is not given. The given is radius of the raindrop is 2 mm. From there you can calculate the mass. How to calculate mass? It's pretty easy, not difficult. Mass you can calculate like density into volume of the raindrop. Density, rain के अंदर material is water. Water की density होती है 1000 kg per meter cube, right. So this is the density, and volume of the raindrop is 4/3 pi r cube, right. This is the volume of a sphere. assuming the raindrop to be spherical, right? To substitute all the values, you can calculate the mass of the raindrop, right? Please don't forget to convert millimeter into meter, right? So mass, you are going to get 3.35 into 10 power minus 5 kg. You just need to substitute the mass here, and the work done by the gravity will come out to be 8.21 into 10 power minus 2 joule, right? Pretty easy. Next part, he's asking what is the work done by gravity in second half, right? Work done by the gravity in second half. Same, no difference at all. Why no difference? जब यहाँ से यहाँ गिरेगा, what is the force by the gravity? It is mg only. What is the displacement? Again 250 meter, right? Again the angle mg will be downward, displacement is also downward, angle is again 0. So again you are going to get the same answer, right? So work done by the gravity in first half is same as work done by the gravity in second half. No difference at all. Okay, what next we have? What is the work done by the resistive force in entire journey if its speed on increase on reaching the ground is 10 meter per second? 10 meter per second. Okay. Now focus on this part. This is pretty important. He's asking what is the work done by the resistive force. First of all, remember raindrop. Two forces are acting. One is mg, gravitational force. Other is resistive force due to air friction, right? Resistive force or viscous force. You have to find first. In first part of the question, we found what is the work done by the gravity, right? It is just force into displacement, right? And now he is asking what is the work done by the resistive force, air resistance during entire journey. Now let's start in a very usual way. Work done by the resistive force or viscous force is equal to viscous force, displacement, cos theta, right? Now, what is the viscous force? क्या हमें विस्कस या ऐसा बोल रहे हैं रेजिस्टिव फोर्स जो एयर फ्रिक्शन की वजह से है, यहाँ पे विस्कस फोर्स लिख सकते हो या रेजिस्टिव फोर्स लिख सकते हो, वन एंड द सेम थिंग. क्या हमें इस फोर्स के बारे में कोई इन्फॉर्मेशन गिवन है क्वेश्चन में? आंसर इज नो, राइट? हमें इतना बोला गया है कि रेन ड्रॉप के ऊपर एक विस्कस फोर्स लग रहा है या रेजिस्टिव फोर्स लग रहा है ड्यू टू एयर फ्रिक्शन, बट ये कितना है दिस इज नॉट एट ऑल गिवन. अगर हमें फोर्स ही नहीं पता तो हम वर्क डन कैसे निकालेंगे, right? Here comes the work energy theorem, very very handy. What is work energy theorem? Work energy theorem says work done on any system by all the forces, work done by all forces on your system is equal to change in kinetic energy of the system. Remember, whenever you fail to find the work done by a usual method, work energy theorem is very very. कौन कौन सी फोर्सेज वर्क डन कर रही हैं? एक विस्कस फोर्स, तो वर्क डन बाय विस्कस फोर्स या रेजिस्टिव फोर्स प्लस वर्क डन बाय ग्रेविटी इज इक्वल टू चेंज इन काइनेटिक एनर्जी ऑफ द सिस्टम. दिस इज व्हाट आई नीड टू फाइंड वर्क डन बाय द रेजिस्टिव फोर्स, जो इस मेथड से हम नहीं निकाल पाए. सो वर्क डन बाय रेजिस्टिव फोर्स प्लस वर्क डन बाय द ग्रेविटी, right? Work done by the gravity, we know the force is mg, displacement is going to be 500 meter, right? Entire journey की बात कर रहा है, first half की बात नहीं कर रहा, right? So entire journey का जो displacement है that is 500 meter. So mgh, force into vertical displacement is equal to change in kinetic energy. Final kinetic energy given क्या है कि जब वो यहाँ पे गिरा, गिरने से जस्ट पहले उसकी जो स्पीड थी दैट वाज 10 मीटर पर सेकेंड. दिस इज गिवन इन द क्वेश्चन. और व्हाट वाज द स्पीड हियर? इट वाज जस्ट ड्रॉप्ड, सो इट वाज 0. सो चेंज इन काइनेटिक एनर्जी मतलब फाइनल काइनेटिक एनर्जी हाफ एम वी स्क्वायर माइनस इनिशियल काइनेटिक एनर्जी हाफ एम जीरो स्क्वायर. सो वर्क डन बाय रेजिस्टिव फोर्स यू हैव हाफ एम वी स्क्वायर माइनस एम जी h, right? H is given to be 500 meter, g we have is 10, mass we calculated in the first part, right? You just need to substitute the mass here. Finally you are going to get work by resistive force is equal to minus 0.15 joule. Now pay attention why the negative sign is coming. That means the work done by the resistive force is negative. Isn't it obvious? The drop was like this, resistive force was acting like this, and the displacement of the drop was downward. So obviously since the direction is opposite, angle between them is 180 degree, right? Hence, the work done with the resistive force is coming out to be negative. So please keep one point in your kitty. The work energy theorem is very helpful to find the work done by unknown forces.